All right, welcome back, everyone. We're going to open up RStudio and get started with some R coding. Okay, so we have the console open right now, but let's say we want to open up this new file that we just made, week 2 intro to R. So everything you do, you're going to want to do in this R script or a new R script that you make every week. One script, one task. Um, so let's type in a simple operation like 3 plus 4. That's the simplest thing you can do in R. And then it shows up here in the console, both the code that we ran and also the output. And you hit Command Enter on a Mac or Control Enter on a PC to enter that line of code. And then Escape, like we talked about in the last video, cancels the line of code. Okay, so R uses order of operations, just like a graphing calculator. So if we plug in something like this, go ahead and guess to yourself what this is going to be, and let's run it. Okay, so first it runs the 3 squared, then it runs the 8 times 3 squared, and then it adds 4. So always use parentheses to make your code more readable. Um, and then, of course, if you want to override the order of operations, you could tell R, actually, I don't want you to evaluate the 8 times 9 first. I want you to do this instead. And you can force a different order that R will do things in by using parentheses, just like you would on a graphing calculator. Okay, so be kind to yourself and use parentheses to help make your code more readable. Another thing R doesn't care about is white space. So this runs exactly the same as if we didn't put any white spaces in there. But if we don't put any white spaces in there, it makes it really hard to read. So use white space. It's your friend. It does not matter in terms of R's output. R does not care. So next thing is how to write a comment. We use this pound symbol, and you can type a line here, comment, and it shows up in blue on my screen, depending on what kind of theme you have going on. It might be a different color. And if I Command Enter, I run that code, nothing happens. I can highlight it, and it will show up, this is a comment, but then it doesn't actually get evaluated. It's not an expression or some kind of mathematical thing that needs to happen. It's just a note to yourself. So these are very important. Use these comments to explain what you're doing in your code and why. This will save you a lot of time in the long run, and your future self will thank you, as will all of your collaborators who are working with you on this project. So absolutely use comments as much as possible to remind yourself what you're doing and why. And the more complex your coding gets, the more important comments are. Okay, so next, scientific notation. We can put in a very small fraction to show our output that R creates is 2 times 10 to the negative 6th. It's just an easier way of dealing with those small numbers. Or we can actually put in scientific notation ourselves, 4 times 10 to the 3, and see what that output looks like. So we can also use mathematical functions like log, sine, and exponent. You can raise a number to a power using the caret, like we already saw up here, 3 raised to the 2nd power. The exponent function raises e to some sort of power. So for instance, if we put exponent of 1, that's just e. So that's a nice shortcut is R stores some important irrational numbers that you might want to use, and that's one of them. Okay, so let's say you wanted to know more about the exponent function. You type in a question mark, and then you write down the name of the function, and that will bring up this help file. Help file has a description of the function and any of the arguments that it takes. Arguments are inputs that the function needs in order to evaluate the output. And then it tells you the output value. that it will return. So for instance, this function only takes one argument, exponent of 1 or exponent of 3, but we only have to put one number inside the parentheses. Now it also has information about the log function, which has 2 arguments. So let's look at these 2 arguments. The first one is just called x. The second one says base equals exponent of 1, which means e to the 1. So whenever you see an argument that says something equals something else, that means it has a default. So if we put log of 100 and we hit enter, it's 4.6 because it defaulted to the base that it assumed we wanted to use, and it used base e. We could change that, but we have to specify it ourselves. So our first argument is our number that we want to evaluate the log of, just like before. But now we write base equals 10. And now we get 2 from evaluating log of 100 in base 10. So the fact we could also remember we have this this variable of x where we evaluated, or we set x equal to 1. And if we put log of x, we can also evaluate the log of a variable that we've previously defined in our script. Now, it's kind of a coincidence that this variable we made is called x, and also the name of this argument that the coder wanted to design was also called x. It doesn't have to be that way. We could put in a variable with our own name. So for instance, if we put y is 1, we could evaluate the log of y, and in our console, the output is exactly the same. So we can put in variables with our own name, but order really matters. So for instance, let's say we put log instead of 100 comma 10, which is what we did last time, which gave us 2. What if we put in log of 10 comma 100? Now it's 0.5. That's because this function assumes that the number you want to evaluate the log of is always going to be the first variable, the first argument, and then the second one is going to be the base, unless you explicitly specify. So for instance, if we said log of base equals 10, x equals 100, now we've specified and we've told it which arguments are which. So now if we evaluate it, it's going to go back to 2. It's always a good idea to label all of your variables and explicitly name which argument you're trying to supply, because especially with more complex functions, there might be a lot of arguments, and it makes your code more readable to other people or yourself 6 months from now if you specify which arguments are which. Additionally, sometimes functions have optional arguments that you need to specify anyway, and they don't have a certain order they're supposed to happen in. You just need to name them explicitly. So it's a good idea to get into the habit of naming your arguments. Okay, so what will happen when we ask R, what is x? This variable that we made earlier today. X is 1, and y is also 1. So what happens if we type in log of x? Log of x is 0, but whenever we try to evaluate x again, it's still 1. So doing a mathematical operation on a variable does not actually change the variable itself. So that's important to know. And additionally, remember back here, we said x is 100 in this log argument definition, but when we ran x again, it still thought x was 1. So why is that? Well, this is within a function, and it's a variable, an argument definition within that function. So this new value that we assigned x is 100, that really only exists within the log function. Just like we don't actually have a variable in our environment right now that's called base. We just told the log function, hey, I know you're looking for something called base. That's the value 10. I want you to put 10 wherever you are expecting to see base. And same thing with X. So it's a little bit subtle, but the X that's in the log function is different from what's actually in our environment. So it's a really good idea to name your variables in your environment differently from the arguments you're trying to pass to other functions, because that can get really confusing. So it would be best if we didn't have a variable called X. We can remove it by saying RMX. Now it disappeared from our values. We can also remove the value Y. Now it's empty. In fact, X is a really bad name for a variable. You want to be really descriptive in your names of variables. So let's try and confuse the programming language some more and try to see if we can force some errors. So we've been taking log of numbers, but what if we try to take the log of a word? So the way you write a word in R is in between some quotes, quotation marks, and it turns a different color. So I'm going to run that. And we get this message that says error in log word non-numeric argument to mathematical function. So this is a really important lesson, is to always, always read the errors and warnings that come up. And so you can understand what happened. Don't just give up and say, oh, it didn't work, or oh, it's an error. Whenever you see that red arrow line, it can be really frustrating and you're like, it doesn't work. But it's very important to read that error message so you can understand what happened. So what happened here? Non-numeric argument. So it was expecting this X. If we see the instructions in the help file for X, it says X has to be a number or a set of numbers called a vector. But we didn't give it a number. We gave it a word. And it was like, hey, I don't know if you know this, but you can't take the log of a word. So it's frustrated because we sent a non-numeric argument to a mathematical function. So it's very important to read the errors and warnings so you can understand what happened. Error messages are designed to be really explanatory and useful. So always work to understand what the problem is. You can fix it yourself, ideally, or know what keywords and concepts to look for on forums. So if I was really confused, I'm like, non-numeric argument, what is that? I could plug in this phrase into Google and look on a help forum online and say, what does non-numeric argument mean? What does it mean when it says non-numeric argument to mathematical function? And see when other people have had the same problem before. So you can look online and see what solutions they used to resolve that error. Resolving errors is a really important coding skill that we want you to learn in this class and get a lot of experience with. Google is a great source of help. You can literally paste the error into Google and see what other people did to fix it. So the next thing that you might see in big scary red letters besides errors are warnings. So what happens if we take the log of negative? So the log of this negative number, negative 40, and it's going to give us a warning message and saying, hey, I produced this thing called NaN, or not a number. So if we run the output, it'll show us that's not a number. And we get this warning message. So same thing, big scary red letters, but it's very important to read it so you can understand what happened. Okay, so let's move on to logical statements and comparisons. So earlier we wrote X, we assigned X the value of 1. We can overwrite that. We can assign X the value of 3. Now, if we look in our environment, X is 3 now. Another way that you can assign a variable instead of using the arrow is a single equal sign. I find that kind of confusing because it looks kind of similar to a different statement that we're about to learn about. So if I ask, what is X? My console will print out X is 2. But what if I wanted to ask a question like, is X equal to 5? Yes or no? Then you would type in 2 equal signs next to each other. And this is the equivalent of asking R a question. Is X equal to 5? And it says false. Nope, X is not 5. So what if the opposite, I ask, well, is X not equal to 5? And that is true. X is not 5. So there's 6 of these different logical statements. There's equals equals, which asks the question, is the first thing equal to the second thing? There's not equals, which we type in using an exclamation point equal sign. There's also the greater than symbol. So we can ask, is X greater than 4? No, right now X is 2. So that is false. We have the less than sign. Is X less than 3? That's true. 2 is less than 3. And we also have the greater than or equal to sign. So is X greater than or equal to 2? And that is true. Vice versa. Is X less than or equal to -1? That is false. So those are our 6 operators. Equals, not equals, greater, less than, greater or equal to, and less than or equal to. So notice that asking those questions is different from setting a value to X. We asked a lot of questions, but X is still 2. Okay, so now let's talk about assigning objects or variables. You can reassign variables, and a reason you might want to do that is a variable is a shortcut for a thing that you're going to use a lot or a thing that might change throughout the course of your script. So let's say, for instance, we have a counter. We're doing something a bunch of times and we want to know how many times we did it. So let's say X is our counter and X is 2. We can refer to X in a new assignment statement. So X is X plus 1. What's going to happen? What is X now? Well, X is 3 because we took 2 and then we added 1 to it. So we can do that repeatedly. And we can also define a new variable based on some operation that we do to an existing variable. So for instance, y equals X plus 2, we take the 3 that exists in X right now, we add 2 to it, and we set that to a new variable that we've defined called y. Now let's add X and Y together and see what happens. We have 8, but notice that that didn't actually change the value of X or Y individually. So X is still 3 and Y is still 5, even though we just evaluated what is X plus Y. So I like to use an arrow sign for assigning variables, because otherwise I think if you just use a single equal sign, it looks kind of like the double equal sign. It can get really confusing. So I like to have things that look really different from each other so I can just when you're skimming a code, you can see really clearly what it says. Okay, so now let's move on to object naming. As we already alluded to, X and Y are kind of bad names for variables because they're not very descriptive. If you're using a counter a certain number of times you want to do a task, sure, it's fine to use a single letter like I or J or M. But otherwise, you want to be really descriptive. So for instance, let's say you have a bunch of samples, field samples that you're bringing in. You might want to label something called number of samples. And let's say you have 50 samples. Now, num samples is equal to 50. Alternatively, you could use this naming convention where you use underscores and use all lowercase letters. Or you could use the naming convention that I used up here, which is the first word is lowercase and then all the words after that are uppercase. It doesn't really matter which naming convention that you use, but it's best to be consistent. Okay, so now we actually have 2 variables that have very similar names that are both equal to 50. And it's important to note that R is case sensitive. So you can get yourself into a lot of trouble. Let's say you accidentally name a variable called number of samples lowercase, and you think that you're changing your original variable, but actually now you just have a new variable that's 40 with num samples lowercase. That's different from the num samples uppercase that you just created. So R is case sensitive, so you have to be really careful with that. Okay, so next let's learn about tab completion. So now that we have a couple of variables, and let's remove some of these because it's getting a little bit chaotic in here. So we'll remove this accidental lowercase one, and let's remove the one that has the uppercase. We'll just keep the one that has the underscore in it. Okay, so one of the drawbacks of using really descriptive, nice variable names is they can take a long time to write and take some time. But fortunately, we don't actually care about that because we have a tool called tab completion. So if I just type the letter N and then I hit tab, a window comes up showing me all the different options of recent variables that I might want that start with the letter N. So, for instance, num samples comes right up and I can click on that. Or I can arrow down and hit enter, um, or just hit tab again. And that will complete the entire word, which is super useful. So next, I want you to try the challenge on the website, write a bit of code to figure out if elephant one weighs more than elephant two. All right, bye everyone.